All right, guys, let's do number 50. A spring canyon is loaded at the edge of a table that is 1.20 meters above the floor, and a steel ball is launched from the canyon with a speed of 35 meters per second above the horizontal. So basically, folks, let me draw it right here. So you have a cannonball, and this cannonball is launched from some heights. I'm going to call it Y naught. So this cannonball is launched at some angle that's going to be at some speed. So Y naught here, in this case, is going to be 1.20 meters. And some V naught with some angle that's going to be 35 degrees. So this cannonball is going to be launched at some angle, theta naught, with some speed, V naught. And the question is asking, all right, find the horizontal displacement component of the ball to the point where it lands on the floor as a function of V naught. So that's pretty straightforward. All right, so let's get started. So this is going to be L. And L is going to be a position vector, and I'm going to use my own notation, as a function of, and X is going to be some velocity, some initial velocity, times cosine of theta times time. And Y is going to be some initial position plus V naught times sine of theta times time minus gt squared over 2. Now, those are your two equations that we're going to be working with. So once you have your equations, we're going to solve for t here, and we're going to chug it in to this other equation. So this is going to be x in terms of V naught. So now, so we replace that, you're going to have your, and I have it here. So now you have some y in terms of V naught, and then let's solve for V naughts. Once you work out all the math, the V naught is going to be some equation x divided by cosine of theta times the square root of g divided by 2 tangent of theta times x minus y1 plus y naught, or I'm just going to rewrite. So I'm going to rewrite this as plus y naught, since y1 is going to be 0 at this point when it hits the ground, because it's asking for the distance. So the distance is when y is 0. So I probably forgot to mention that part. But anyways, regardless, folks, that's going to be your equation that they're asking. That's going to be part A. So we're done. You could simplify this further if you want. I don't think I need to. Really, you don't really need to. So now we're going to just evaluate for part B at what is this V naught. Oh my God, I actually messed up. I think I was looking at my wrong notes here. Oh, that's embarrassing. Anyways. This is going to be V naught cosine of theta multiplied by V naught sine of theta naught plus the square root of V square sine square of theta plus 2gh all over g. There we go. There's that equation. Okay, that's what we want. Okay. Oh my God. All right. So now for part B. Now we're going to evaluate the distance x when. All right. So once you got everything together, so let's evaluate when V naught here is going to be 0.100 meters per second. So if you let v naught be that, your x here is going to be, well, I have, let me convert that. 4.10 centimeters per second. And that's answer for part C. So this is just pretty straightforward at this point. So let's evaluate when C equals 100 meters per second. So I'm going to store that into V. And actually, I think there's a little more involved in this problem. So when V naught is going to be that, X is going to be 960.58 meters per second. And there's more to this. All right. I'm not going to fully answer it completely on these problems because I don't really want to simplify this. I don't want to evaluate this when V naught is 0. I think well, actually, you can kind of tell if V naught is 0, then you'd be left with like 2GH over G. Let's actually kind of do that. Let me see what it's asking. So we just answered part A, part B, part C. Assume that V naught is close to 0, but not equal to 0. Show that one term of the answer dominates that. So I'm going to put this in my calculator. I'm going to put 0.00001 in terms of my V naught. I'm going to evaluate this. I'm going to show you the end result that I got. And I got 0. So I got when V naught equals 0 meters per second, your X is going to be 0 meters. That's what I end up getting in the end. So I don't know. They want you to simplify this. So part E. And if V is very large, so I'm just going to store that. I'm just going to put this on my calculator. I don't really care anymore. So if V naught is like, I don't know, infinity, then X would just be infinity. So that's the value. And part E, F, overall the shape of the function, that's a function of time. Well, this is part F right here. So F is just going to be a parabola. All right, we're done.